So we are going to look at 2-3 factored form of a quadratic function. So just a reminder, when we talk about a quadratic function, we are talking about a function that's in the form, let's get this going, here we go, y equals ax squared plus bx plus c, or we also have vertex form y equals a times x minus h squared plus k. But the point is that x is squared. That's our key, that this is a U-shaped graph depending on a, either opening up or down. If a is negative, it opens down. A is positive, it opens up. So what is the factored form of a quadratic? So factored form of a quadratic looks like factors. So parentheses, and then x minus or plus a number, and x minus or plus another number. And so it's in factored form. You probably factored in Algebra 1. So this is what we're looking at. And how it's helpful is this will help us find x-intercepts. So I will set these factors equal to 0. And so this is called the zero product property. And so to find the x-intercepts, I set each factor equal to 0 because the zero product property says when I have factors, one factor is equal to 0 or the other factor is equal to 0. All right, so I kind of answered several questions here, but how can we find the factored form of a quadratic function when it's written in standard form? Well, a couple of different ways. If a is 1, here, then we can just factor it. We look for numbers that multiply to be c and add to be b. If a is something other than 1, then we look at the AC method, and we will look at both of those. All right, so again, the zero product property says if I have factors, and you can have more than 2 factors, but right now we're only dealing with 2 factors, and they're equal to 0, that either the first factor is equal to 0, so either x equals a or x equals b when I set both of these equal to 0. So numbers that make each factor 0 are solutions to the equation. All right, so let's look at number 1. We're going to use the key features to graph the quadratics, and we're going to state the domain and range. So first, let's factor this first quadratic. So I see that a is 1, so I can just look for numbers that multiply to be negative 42 and add to be negative 1. All right, so I have numbers that multiply to be negative 42 and add to be negative 1 would be negative 7 times positive 6 gives me negative 42, and negative 7 plus 6 gives me negative 1. Now, we can run through all of the factors, but the smaller this number is, the closer my factors are together. Like, I know it's not 1 and 42 because 1 minus 42 is 41. That's way far away from 1. So the smaller this number is, the closer my factors are. All right, so my x-intercepts are x minus 7, x plus 6 equals 0. That's how I find my x-intercepts, because this guy factored into x minus 7, x plus 6. Oh, that's yucky. So I am going to plug in 0 for y. Remember, f of x is just fancy y. So I'm going to plug in 0 for y and solve. So the zero product property says set each factor equal to 0. So I'm going to add 7 to both sides, and I get x equals 7. And then subtract 6 on this one from both sides, and I get x equals negative 6. So I'm at negative 6 with a dot, and I'm at positive 7 with a dot. All right, I also know that I have a y-intercept at negative 42. All right, so I'm going to change what I'm counting by on my graph, And let's see, we probably need this to go to 50, don't we? So let's change these. This will be negative 10, negative 20, negative 30, negative 40, and negative 50. All right, so negative 42 would be about right there. All right, let's go ahead and find the vertex. So I do the opposite of B. So B is negative 1, A is 1, C is negative 42. So the opposite of B is positive 1 over 2 times 1. That's my x-coordinate of the vertex. So my x-coordinate is 1/2. And then I'll plug in 1/2 and see what f of 1/2 is. And so that will be 1/2 squared minus 1/2 minus 42. So that's 1/4 minus 1/2 minus 42. 1/4 minus 1/2 is negative 1/4. That's like a quarter and 50 cents. So it's negative quarter. And minus 42 is negative 42 and a fourth. So I'm at 1/2 negative 42 and a fourth, and I have that mirror point of my y-intercept, and then I'm heading toward this x-intercept, and I'm heading toward this other x-intercept, and there's my parabola. There it goes. Okay. All right, so there's my parabola, opens up. I have my mirror points. My domain is all real numbers. My range is negative 42 to infinity. I could talk about where this function is decreasing and then where it's increasing, and the change happens at 1/2. So it'd be decreasing from negative infinity to negative or to positive 1/2, and then increasing from 1/2 to positive infinity. I could talk about where the graph is above the x-axis, where it's positive. So that'd be negative infinity to negative 6, and then from 7 to infinity, or where it's negative between negative 6 and 7. So we could talk about all of those things, and all the things that we've talked about in the past. So make sure that you can answer those questions. All right, let's talk about this one with the AC method. So I know this parabola opens down, and I want numbers that multiply to be negative 10 and add to be 3. So I have 1 and 10. That's not going to work. That's going to give me, when I subtract those, that's going to give me 9. And then I have 2 and 5, and I want a positive 3, so the 2 needs to be negative, because negative 2 plus 5 is positive 3. Now this is AC method because I have a negative 2 here. It doesn't matter which factor you put first, but I'm going to rename this middle term with negative 2x and 5x. So I have negative 2x squared minus 2x plus 5x plus 5. So this is the AC method. I multiplied A and C, and then I'm going to take out common factors. So I'm going to factor out a negative 2x, and that leaves me x plus 1. And then I'm going to factor out a 5, and that leaves me an x plus 1. And then I'm going to factor out the common factor of x plus 1. And my leftovers are negative 2x plus 5. So that is factored form of h of x, and I've dipped into the vertex section, but that's okay. Now I'm going to find x-intercept, so I'm going to let y be 0. And by the way, if you want to flip this around, you can totally do that. So I have x plus 1 equals 0, just setting each factor equal to 0, and negative 2x plus 5 equals 0. We don't really need the parentheses. I'm going to drop them on this next row, and you could take out the last step where I wrote the parentheses. So I get x equals negative 1 when I subtract 1 from both sides, subtracting 5 from both sides, and then dividing by negative 2. I get x equals 2.5, 5 halves or 2.5. So I have an x-intercept at 2.5, and I have an x-intercept at negative 1. I can find the vertex by adding these two together. Well, actually, yeah, adding them together and dividing by 2, I can find the middle. That's the midpoint, which you did in Algebra 1, probably a little bit in geometry. So you can do it that way. I can also come back and do opposite of b over 2a to find the vertex. So I'm going to let you guys finish that one, plug the vertex in, find the y value, and finish graphing. We know this opens down. We also know that we have a y-intercept at 0, 5, because that's C, so we can do our mirror point. So my vertex should be in here somewhere, opening down. I'm going to let you guys finish that one for sake of time. All right, so let's look at number 2. There are 3 levels at a driving range. Golf in the sky. Jessica and her 3 friends are hitting golf balls from the 2nd level, which is 32 feet high. I think it's supposed to say, what is the height of the ball? The height, this should say height of the ball at X seconds after Jessica hits it is h of x equals negative 16x squared plus 16x plus 32. When does a ball hit the ground? So I know I can graph that on Desmos. I know this opens down, so let's write down the things we know. I know we are measuring this in feet, and the question is at what time? So when, I'm looking for the time that it hits the ground, and so we will graph that and see where it hits the x-axis. So I will let you guys do that. Providing evidence, I'll let you graph it on Desmos, but providing the evidence, I'm plugging 0 in for the height, and then I'm going to factor. So one of the first things that I want to do is look for a greatest common factor. And my greatest common factor between all 3 terms is negative 16. So I'm going to factor that out, and that makes positive x squared minus x minus 2. And so when I set negative 16 equal to 0, because that would be one of my factors, I'm not going to get anything, but I can factor this, numbers that multiply to be negative 2 and add to be negative 1, and that would be negative 2 and positive 1. So I have 0 equals negative 16, x minus 2, x plus 1, and then I set these 3 factors equal to 0. Negative 16 equals 0 doesn't even make sense. X minus 2 equals 0. I add 2 to both sides, and I get x equals 2. That would be 2 seconds, because it said x seconds. X plus 1 equals 0. X equals negative 1, which would be negative 1 seconds. We are not dealing with time travel, so we don't want the negative time. All right, so that's how you solve that algebraically. Again, check it on Desmos before you start or after you finish. Okay, determine the intervals, or determine the positive and negative intervals where the graph is increasing and decreasing. Wait, it should say determine where the graph is positive and negative. I think the way it's written is maybe how it's written on the CCA, determine the positive and negative intervals. So know that when it asks for the positive and negative intervals, it's asking for intervals where the graph is above and below the x-axis. And then also we're going to say where the graph is increasing and decreasing. So let's start with positive and negative intervals. So remember that goes off of my x-intercepts. Where is my graph above the x-axis and where is it below? So you can pause the video, try it yourself. All right, so it's above from negative infinity to negative 4. And I know we've talked about this a little bit. If that's confusing, then start out where it's below. So it's below between negative 4 and 3. My graph is below the x-axis. I can see that. So it's below from negative 4 to 3. And it's above the other places, right? It's above from negative infinity to negative 4 and then 3 to infinity. I don't like it when it does that. 3 to infinity. All right, let's talk about increasing and decreasing. So my graph is increasing and decreasing. Why is it doing that? Okay. I don't know what's happening. It's increasing and decreasing based on this vertex, and we can do opposite of b over 2a based on the vertex, or I can find the average between these two. So -4 plus 3 divided by 2 is -1 over 2. So at -1/2, and I don't need the y value, but at -1/2, that would be the y value of my vertex. So from negative infinity to -1/2, my graph is decreasing. So I'm writing that roller coaster down, and then from -1/2 to infinity, my graph is increasing, writing that roller coaster back up. So notice I didn't even need to find the y value. I know it's lower than -12. Didn't even need it. Okay, so let's talk about, I'm going to leave that other one, put that back over here. What is happening? Okay, you know what it's saying. All right, could you not? Okay, let's talk about number 4. Write the equation of the parabola in factored form, then state the answer in standard form. So when we write the equation in factored form, we know we can do this on Desmos and get it in standard form, but it asks for it in factored form first. So I have y equals a times x minus my first x-intercept times x minus my second x-intercept. So y equals a times x plus 2 and excuse me, x plus 1. I plug in the point -320 to find the value of a. So y is 20. I don't know a. I'm plugging in -3 for x, and then I'm going to solve for a. So this is going to feel familiar. We did this with vertex form. So 20 equals a times -1 times -2. So I multiply these two numbers together. So 20 equals a times 2, or 2a. And then I divide by 2, and I get a is 10. All right, I'm going to go back to this equation, and I'm going to plug 10 in for a, and that's my equation. So y equals 10 times x plus 2 times x plus 1. And that's my equation. I left you 2 problems to do, actually 3, counting the one above. I left you 2 problems to try, and we'll talk about them when I see you again. Bye, guys.